Hello. Today we're going to be discussing the decaffeination of a coffee bean using supercritical CO2. The way this presentation will be structured is first we're going to talk about the principle behind the process of using CO2 or supercritical fluid to remove caffeine from a coffee bean. Then we're going to move into the actual process of how supercritical CO2 removes caffeine. Then we're going to move into why exactly is this process important, or why is it important to use supercritical fluids in processes. So you may be asking yourself exactly what is a supercritical fluid? So we all know that in general there are three phases: the solid phase, the liquid phase, and the gas phase. And those phases exist at a certain temperature, maybe at a certain pressure. We talk about a gas. But a supercritical fluid is where high pressure and high temperature is placed on a substitute where it's no distinct line between a gas and a liquid phase. The gas and the liquid phase are homogeneous, so you have both coexisting. So because of this property, this gives us some unique characteristic or some unique things you can do with supercritical fluid. For one, supercritical fluids allow us to diffuse through solid mass. So if we take a supercritical fluid, we can diffuse through solid mass because, like I was saying, it's no distinct line. So you have a homogeneous mixture between the gas and liquid. And because we have that liquid side of it, it can act more as a solvent also. So moving on, we're going to look at the process of supercritical CO taking out caffeine. So first, our beans are soaked in water. This allows the beans to swell, and when it swells, the water can then act as a solvent for the caffeine. So the soaked beans are then put into an extraction vessel. In this extraction vessel, we have supercritical CO2 pumped into the extraction vessel. This allows, under high pressure and temperature, this allows the CO2 to bind with the caffeine. So when it binds with the caffeine, the then decaffeinated beans are they fall out and they are collected and then they are shipped out to manufacturers for roastings and grinding for decaffeinated coffees. The CO2, the supercritical CO2 and caffeine then go into this absorption vessel. In this absorption vessel, we have water that is added. Water is added because the water will bind to the caffeine molecules. So in this vessel, we have the water binding to the caffeine and we have free CO2 at this point. So the caffeine in the water will then fall out. When the caffeine and water fall out, it is collected and then it is sent to manufacturers for things like energy drinks. And because we have purified the CO, because we have removed the caffeine from what was binding to the CO is then recycled and then it can be put back into the process over here. So we have a recyclable process going on. Now, why is this important? This is important because supercritical fluids are classified as a green technology. This means that it is eco-friendly, so it has a less of an impact on the environment than some of our organic solvents today. So the more supercritical techniques that we are able to use, the less amount of organic solvent that we'll have to use for processes like this. So we are making the planet healthier. Thank you for your time, and I hope I have clearly explained this.